Hey there, Daniel. I really do wish I could recycle these gloves. It burdens me considerably that I throw them out every time. I feel like I should be able to do something about washing them, or I don't know. I feel like I should be able to use them 2 or 3 times. Hey, Gavin Brown, doing good, thanks. Alright, so we're going to do the mini version of the board. So obviously this board, I just realised my second light's not on because it does not come on automatically. That's better. Yeah, so this board basically does the same thing as this one, except that it doesn't have the display. And I was thinking about it. Yeah, I've got a dodgy connection here somewhere. Anyway, dodgy soldering. I was thinking about it. That's a micro who's already been sorted. I don't need to have the 2 USB mini ports on this because this is not a display board. It's simply just a inline tap. I can just pick one side or the other, and then you can just orientate the board around however you find most comfortable to be the inline tap for the USB-C. So yeah, we only have to do one port on that one. Hey Bob, Tim, sorry, and Fullwave, Eric, hello, Eric and Andrew Hughes. Alright, shuffle these boards. See which one I'm going to use. Eeny, meeny, miny, mo. Hey there, Ed. Okay, so we need to turn the board the right way up. We need a 212, CH340, an INA 219, regulate, all the usual stuff. And I've got to sneeze. Why? Why do I have to sneeze all the time? Must be something in this room. Maybe it's me. Maybe I'm allergic to myself. Okay, let's get the various bits and pieces out. That's one USB mini connector. I do not use USB micro because it is not a good... Realistically, it's not a good connector for sort of tools and things like that. It's just a little bit too fragile. All too easy to break those tongues out. I'm gonna have to steal a shunt from somewhere. Realistically, I think this board would probably be the easier one for me to move around the world, sell and stuff like that. Regulator. Certainly it'll be a lot cheaper, a lot less complicated. So we've got hardware and knobs. Microcontroller. The 212s are in a different box. 212s are in here. Hey Tradie Trev, how's it going, mate? How'd your week go? Anything interesting on your side? Hey there, Miles and PR. Where did I put my CH340? Not in here? Hey, Michael K from Amsterdam. Amsterdam. Very liberal country in some ways. Oops. A laptop. Alright, I'm actually... I gotta find myself I can't destroy this because this is actually the very first sort of USB-C meter that I did. That's prototype 1, so to speak. But I am out of 50 milliohm shunts. Where am I? It's interesting. That's a 50 milliohm shunt there, and yeah, I wonder where that came from. I'm gonna go check another box. Hey, Mark Tabor. Let's see. The trouble is, you start getting lots and lots of prototype boxes all over the place, and you start forgetting what you've got where. Okay, you guys are all... What is circuit boards? Now I've definitely got a few more of the original USB-C sort of units that came over. So it'd be sad if I have to pull anything off one of my existing prototypes, because I kind of like to keep the prototypes as a history of the device. But sometimes you have to sacrifice things. All I need is one more. Just one more. Ooh, is that you in there? Talk to me. Bit of a weird question for me. Ooh, idea. If you were in a repair business, would you push for a stipulation in the contract that work done by them must be warranted by them? Yeah, I mean, it's... Or maybe if you can't get that, stipulate that you can't be held responsible for prior work. The prior work has to be renegotiated or something like that. Yeah, it's certainly you'd want to be protecting yourself, I agree. Ah, here we go. I found the ones I'm after. Because yeah, I mean that's a big unknown for you. Okay, sorry folks, I gotta blow my nose, it's really getting to me. As far as I know, though, under company law and things like that, when you acquire companies, you do also acquire whatever liabilities they have. So, you know, that's part of the whole negotiation process. You take on the company, you take on the liabilities. Okay, so we've got our 50 million, we've got our INA. That's good. Now I don't know how smoothly this build's going to go, or rather, I think the build will be fine, but I'm not sure how the programming's going to go. Because the downside of if you want to check all their prior work, that's the problem. You're going to have to suck up so much time digging through their existing jobs or what would technically still be under warranty. That's why so many times it's just easier not to buy other companies like that. Just start your own or expand your own. But obviously there's a reason why you're looking at this one. Geez, what they use? They use lead-free or something on this? Okay, it's got a bit soft there. I'm only on a low air temperature on this, that's why it's a bit slow. But to be fair, Miles, I'm not really good at business acquisitions or anything like that. In fact, I'm downright terrible at it. It's one of the reasons why I've sort of stayed a small-time player like I am, because I really don't have the business acumen to deal with that sort of stuff. Main reason is customer base. Buddies with Castle Hill Apple Store. Oh, that's very nice. Yeah, that's actually very handy. Damn it, now you're making me jealous. Yeah, I don't think you're asking too much. Certainly, I think it has to be something that you really do need to be made very clear, because otherwise, yeah, I mean, it's the sort of thing that could easily tank a business. So I think you're being quite smart, savvy, thinking of that in advance. I'd be the sort of idiot that would walk right into that and then only sort of realise afterwards what I've done. So yeah, kudos to you for actually thinking about it before it becomes a problem. Okay, what have we got here? We've got our 212. So this is our Atmel controller, little microcontroller. This is the same one we use on the microscope ring light. They're nice controllers. They're a little bit under $1 each, but they're very, very useful. I think the hardest thing for me with these was simply getting used to their new style of programming compared to the original series AVR Tinies that I've spent the last 15 years using. Right, that's going to have to get hot aired down because it's got dags sitting under the bottom of it, making it difficult for me to put it down. Yeah, believe it, it's very cheap, but it's also because it's like a new process, whereas sort of things like the original ones that I still use, they're still very expensive, and I think it's because they use a much larger silicon die process, and it's also why they're in rather short supply and expensive, whereas these ones are everywhere and cheap, because these obviously use a much smaller fabrication process. Yeah, DAGs are. I thought people in Florida would know all about DAGs. They're like the little bits that hang off. The whole US presidency vote thing came down to. Oh, that's right. You guys were calling them Chads. That's right. Yeah, Chads. Dingleberries. Yeah, that's the other word. Yeah. Or dangleberries. You can always make a Christmas song out of that. Dingleberry, dingleberry. Yeah, I'm going to shut up right now. Hey, Vladimir. Welcome. Hey, Nelson. Yes, it's been a little while. When I get the, if I get the chip controllers for the ones that are going to go here, that go the higher voltage and everything, I'll actually reduce this shunt resistor down to probably, I'm thinking, yeah, I really actually want 20 milliohms, but I think I'm going to have to go to 10. You can get, I think, 22 milliohms. And by the way, yeah, I am aware this is all crooked and everything. I'm going to have to hot air it down. It had little dags, chads, dregs, spikes, whatever you want to call them. It had them. Realistically though, the size of your shunt tends to be dictated, well, it is dictated more by whatever the maximum current you want to deal with is. The voltage is generally irrelevant, so long as you're within the limits of the actual part itself. What is the shunt resistor for and how are they different to normal resistor? Shunt resistors are basically just very low value resistors. The point is that as current goes across it, a small voltage develops across it, and that small voltage is then read by the sensor, and from that you can work out how much current is going across it. So you want a resistor that's small enough to not overly impact the amount of waste. Well, you don't want too much waste power burning up in there, but you want it large enough so that you've got some reasonable resolution or precision in how much current is going across. So it's a balancing game. So in this case we've got 50 milliohms. That's pretty good for up to about 4 amps. So 50 milliohms, 4 amps, 5, 4, that's like 2 watts maximum it will dissipate, which is a fair bit. You wouldn't really want too much more than that going through there. There are other ways of measuring current. You can use a Hall sensor. That's a little more complicated, hard to get the same degree of resolution, a little more expensive, but on the other hand you can get some exceptionally high currents that you can detect, but you lose the precision, or the resolution really I should say. But yeah, basically it is just a resistor. It's just simply a type of we use for that purpose. Yeah, and now where are my resistors? Okay, gotta go my box of goodies now. We start all the little itsy bitsy bits. Geez, I didn't even put a LED on this one. Ah. What a horrible man I am. At least I don't think I have I? Oh no, I did. Yay, I'm saved. I did put an LED on it. Usually with shunts, most of them are around about, usually sort of like 1 to 5% depending. You can get 0.1% sort of things or really low values, but you're going to pay a fairly hefty price for it. The other thing you've got to watch out for is that obviously as the shunt gets hot, it will change its resistance slightly, so you've got to compensate for that sometimes. Subsequently, that's why you try to go for the lowest possible shunt resistance you can to get the resolution you want. Less waste, less heat, less compensation required. Yeah, you kind of half laugh about putting a thermistor on the or temperature sensor, but I actually did that on my low ohms meter. I had a special 4-wire resistor, and it was like a 0.01% tolerance on it. It was a high precision, like the resistor cost something like $60 or something like that. And then I also had on it a temperature sensor so that I could immediately know what temperature it was and compensate accordingly. So yeah, when you start doing precision measurement, yeah, you do start to do all this sort of stuff. I haven't, Kristen, I haven't played around with any of those. I mean, most of them you can do adjustable gain. Like I know even these INA 219s, you can adjustable gain them. But I gotta admit, I kind of prefer to fix it for what I want and not have to worry about adjusting it. But certainly, you can treat it like a multimeter basically. So what you do is you go for the low range, the high, I want to say high resolution, but it's kind of counterintuitive that. Anyway, the very fine resolution, and then when you max out on that, you then step up to a slightly higher resolution. But usually for that, you switch shunts. So you'll have, say, a 50 milliohm shunt, a 5 milliohm shunt, and then when you exceed the range on the 50 milliohm, you switch down to the 5. But that can cause some issues with whatever equipment is attached. Some equipment does not enjoy having the line resistance changed on the fly like that. Whereas with multimeters, it's not too much of a problem. I mean, it can... damn it, I lost my capacitor. It can cause grief. The other area where it can cause grief is that the shunt resistance is too high right from the start, and you won't even get... the device won't even work properly. So yeah, you sort of look at your situation, what you're trying to measure, and you try and pick the best option from that. It's certainly very interesting when you start having to deal with high precision equipment. And then of course you start doing things like having a intentionally warmed up set of sensors. So you put them in a little oven, a temperature controlled oven on the board itself. Most like 7-8 digit type equipment has that. And the main reason is that even though it's warmer and whatnot, if it's a fixed temperature, then you know how to deal with it. Damn it, I just realised I kind of botch that up a little bit. It's supposed to go that way. There we go. Yeah, it's more, if you know what you've got, then it's easy to work with. If you don't know what you got, that's when you've got to go through all the complicated part of calculating and sensing. Yeah, the environment starts becoming a real factor. I know with the low ohms meter that I had, just moving your hand around or shadowing the resistor, the 4-wire sensor, that would be enough to make it change value. So obviously you've got to shield all that up, protect it and things like that. Okay, I need I don't know what size resistor I want for that. I always forget. I think it's a 150 that I use. What the hell, that's an 805. That's a huge resistor physically. I need something a bit smaller physically. There we go. Was it 220 or was it 150? I can't remember. Well, since this has no display, I'm going to go with a 150. That's going to turbocharge that LED a little bit. It's a 3V3 line, 3.3 volts, so I think 150 will be perfectly fine. It's a yellow-green LED. Hey, good morning, Ian. Oh, that's god-awful, too much solder there, but oh well. Doomed now. It's already committed. Okay, we need our two 10 ohm resistors here. Interestingly enough, these 10 ohm resistors don't really play a lot of part in the... You would think putting resistance in line on a shunt would cause weird issues, but it doesn't. They're mainly there just to limit the amount of instantaneous current that can go in. They're more protection than anything else. They don't even have to be a match pair. Because technically speaking, if that was a perfect sensor, you could have any value resistors there and not matched, and it would still be fine. Mostly it just sort of limits the slew rate of the sensing of the ADC converter. Should all resistors reach short in diode mode? No, they should not. No. The diode mode will represent whatever voltage is required to establish... the voltage you see in the diode mode is whatever is required to produce a certain current over a device. So usually I think it's 1 milliamp, sometimes it's 2 milliamps for diode measurement. So what the meter does is it keeps cranking up the voltage until it sees the 1 milliamp or 2 milliamp flowing across the device. So you can just use Ohm's law and work out what diode mode you would see across a particular resistor. Yeah, you really don't want to put a giga. You don't want to put a giga tester on delicate electronics. Okay, these two here are just our I2C pull-up resistors. Tradie, calibrate what you're talking about. Which things are you talking about calibrating? Forgot to put the flux down. Current and voltage measurement. Ah, right, okay. Well, because we know the value of the shunt, and the data sheet tells us what it tells us sort of like what value to expect for whatever voltage it receives in. There are tables for it. So choosing the shunt it's up to you I should just say the sensor just simply punches out a number between minus 4096 to plus 4096, and that really depends on what that actually represents in real life. Depends on what size your shunt is. So basically, it just simply says full scale is 4096 and minus 4096. And I think full scale voltage internally is something like 1 volt or something like that. So yeah, you just punch in the math and it comes out like that. Fortunately, it's a lot easier these days than it used to be. Yeah, I forget what the reference voltage is inside the INA219 sensor chip, but basically that reference voltage is what it says is, okay, this is our full-scale deflection voltage. So when the voltage across your shunt is as big as our reference, then we're going to call that 4096. And that's basically how it works. Like I said, these days it's profoundly easy compared to how it used to be. I'm very happy for modern technology. Yeah, so it just simply, like I said, it has its reference voltage on one hand, and then it looks at what you're putting in across that shunt, and say if it's half the shunt value, half the reference, it'll say, okay, what's half of 4096? 2048, and it'll punch out that value. And because you know what your shunt is, and you know what the reference voltage is, then you can work out what the current is. Anyway, it's fairly trivial arithmetic. Arrhythmia. Oh god, I can't even say anything. And the nice thing is, most of these devices do have internal compensation for a lot of stuff, so you don't even have to worry about non-linearity issues. And if there is some sort of non-linearity that they can't or they haven't bothered to factor out in the chip itself, they'll give you the table and say, you know, at this temperature it's going to be this much that you have to adjust by. For these sort of jobs, you don't care. I'll bring up the data sheet later and show you. We'll probably have to visit it so that I can work out if I've got the programming right on this or not. Probably the thing that gets a lot of people with shunts initially is why we have what we call 4-wire resistors, and there's a very good reason for that. We also call them Kelvin connections. Basically, it's a way of getting the value of the voltage across the resistor without that value being influenced by the wire bringing the power in and out of the resistor. We've got one more connector to go. I'm trying to decide which way I'm going to go. It doesn't really matter, because that's what I was talking about. It really doesn't matter which way we put this. Yeah, as I say, it's modern day chips make it absolutely trivial to do this sort of stuff. Having microcontrollers for $1, I mean, back in the 90s, something like that's would have been a couple of $100 for something that could do what this $1 chip, whereas that chip could do, and it would have been huge. And most of the time we were using what we call PLAs, which are basically, they are a big fat array of gates, and then you burn out various connections to the gates to make the logic that you want. So that was probably about where we were, and we're pretty happy about even having that. At the time, I think the controllers that we had were things like the 6811s, 68HC11s, and they were probably they were bigger than a Raspberry Pi. They're still used to this day. 68 series is very embedded in the industry. That's a really badly placed mini connector. It's not shorted, but I'm really not happy with it. I might try and just reflow it, get it to sit back. Hey there, Graham. Shouldn't you be working? Yeah, I'm just not happy with how this one's sitting. It's a little bit skew. A bit like Graham's goatee. Hey, Warren. It's okay, Graham. Your goatee's not skew. I'm just lashing out. I mean, Caradog's got the mutton chops, you've got the goatee. Sort of didn't leave anything for the rest of us. Yeah, it's interesting. This is really... I was about to say, this is really not moving. There it goes. The jobs where you're just happy to break even, get rid of it. Yep. Oh, yeah. Yeah. And the customer thinks you're being so nice, and it's like, believe me, just take it away. Take it away. I think we're done. That's the programming header there. But not sure if I... yeah, crap. I'm gonna have to put a header on it. I didn't want to. It makes it look ugly, but I'm gonna have to. If this wasn't a prototype, I would leave it without the header because I can just sort of like contact program it. But nope. I'm gonna have to solder that header in. Maybe I can flip it on the back side. I'll put it on here. Graham, those jobs just always pile up. Like you get really happy that you clear out a bunch of jobs, and then slowly those damn things just crawl their way back into your inventory. Like I know when I clear out my slots, I'm like, finally, I'm never going to let them get choked up again with crap. 2 days later. Build up. It's not going to sit flat, I agree. But it's not going to matter because it's not a visual... Oh wow, that's wonky. Oh well. Yeah, I don't think I had anything else to put on the board. Yeah, it looks good to me. But it gives it a nice little tilt. Well, the very first test we do is just see if it even accepts. Okay, we have a green light. So that's it. It glows green, ship it. Okay, we're going to wash it down with some IPA and paper. Hey there, Toby. I could certainly make this board quite a bit smaller if I wanted, but I kind of felt, yeah, if people want to put this into a box, then having the slightly larger size and having decent mount points was probably more useful. Looks clean-ish enough. You ever tried PCB cleaner spray? Yeah, I have, Miles. I find it. Let's see, what have I got here? Oh, this is probably Repco one. But yeah, I've tried a few different ones, and I will occasionally use it for something particularly stubborn, but for the most part I find it's quite obnoxious and irritating. Kind of like me. Electric toothbrush will be on sale on Northridge Fixing? What? Seriously? It's kind of weird. Yeah, it stinks to high heaven and it drives me insane. I'm very sensitive to fumes and things like that. Okay. Let's see if this... See if it plugs in and detects the USB. Okay, so we've got the port at least, so that's good. Okay. Used to have been an ex-refrigeration mechanic. Goodness knows how many horrendous things you've unintentionally inhaled. Yeah, it's not the sort of business for me. Yep, okay, just making sure I got that right. R32. What's the worst smelling one? Pure ammonia. Do you actually do pure ammonia ones anymore, or they don't do them at all? Sort of see it sort of coming back. Alright, so it looks like I am going to have to actually completely redo this firmware. So I've got firmware for the Tiny 414 with the 16:2 display, which is this one here, this large one. And we have it for the 8:2, which is the slightly smaller one. We've also got it for the Tiny 25. So now we have to make it for the Tiny 212 without a display. B-Blood, stop saying like that. So we're going to go over the T414 16:2 and T212. You don't need the LCD portion. Okay, basically in theory, I should only have to just simply change the configurations. And we also can get rid of all of the display stuff, which basically is most of this, I think. Actually, I don't need any of this. This is basically, when you take the display out, this is it. All we do is read the shunt, and then we read the bus voltage, like as in 20 volts, whatever it is, and then we compose it into a 4 hex sequence, and we send it out. Then we wait 50 milliseconds and we do it again. That is just how damn simple it is. Now though, we do have to go along and change some things because we need to check the data sheet to find out what pins we're using. Maybe I specified enough here. Which one's this? Okay, this is the mini. Yeah, someone didn't make it big enough. Okay, PA2 is the serial port. Can't wear the glasses while doing that. Okay, so the serial port's done. We don't need to initialize the LCD. We don't need that, I think. Do we? Maybe we do. Yes, we do. Okay. And we've got to go into the I2C section and change the ports and pins. Hey, Electro Rep. Let's see, I2C clock is on PA7. Okay, PA7. Data is on PA1. That should be all that's required for that. Okay, interesting. I've got two instances of serial port gibberish here. This is a problem. Oh well, we'll readjust it here. This is all bit bash stuff. It's not using the proper serial port interface. These chips do actually have hardware built into them for dealing with this sort of stuff, but because I wanted the software to work basically across any microcontroller, I made it so it's all software bit bashed. And with devices like what we're doing here, timing and performance is not so critical that you need to use the hardware. So it gives it a good bit of portability, and other people can then use that software bit bash until they sort out their own more efficient way. Like I said, make it work first, and then after you've made it work, then you can go out and make it faster. Yeah, that's to be expected. Because that script is wanting to talk to a 414, but we've got a 212. Hex file contains data outside of enemy. What? It's telling me, trying to tell me that basically the program's too big. I'm probably including something I shouldn't, like the LCD. I'm screwing up something somewhere. There's no way that this should be over 2K. Unless for some reason it isn't even doing any. Yeah, I'm a little bit stumped here. It's trying to tell me that it's producing a 32K. Let's see. Hmm. Abort. Yeah, there's no way this program should be that big. Even on the worst of days. I mean, this looks really verbose, but it's compacts down to some very simple code. It could be the snprintf function. I'm very surprised. Nope. I'm just going to comment that out and see if it. Wow, it is the sprintf. Wow. Okay. Wow. Hmm. Yeah, save me a bite with the. Alright, okay, so it looks like they've kind of got an overpacked sprintf or snprintf, it doesn't really matter between the two. So that's not a huge problem. We can create our own function to do this. I just sort of had hoped just to use sprintf because it is so convenient. Yeah. Alright, so we just basically have to create our own hex to string converter. It's a bit of an ugly way of doing this, but oh well. Geez, I've got to have it somewhere else. I've done it. No? Yeah. Weird. Okay. There's many ways to do this function. Naturally, I'm forgetting everything now. Let's see. And then we need another function that actually says I really should just do this as a map anyway. There are much faster ways of doing this, so forgive me for being a horrible person here. My body can't handle this. If H. No error checking on that, of course. Leave it to the audience to work out if that's correct or not. Just string terminating it. Okay, so basically now do oh I'm gonna be really dirty here. Dirty boy, dirty boy. Anyway. Oh god, I can't even spell tonight. And then so we've got 8. That's not right. That's not right. What's code review? Never heard of code review. Sounds like a load of crap. Huzzah, it actually programmed it. Code review sounds very nerdy. I don't think it's something I would ever partake in. Okay, so we're on 0. Need to xkill. Okay. Well, I has selected it, so let's get my phone. You can see it up there on the screen. It's got power, and there you go. It's working. Crikey, I actually did my job properly. I'm shocked. Shocked, I'm telling you. Oh, not that shocked. Yeah, it works. But interesting that we had to make our own sort of little string generator simply because the built-in sprintf was just too big. It is the whole printf series family of functions in C is a very complicated function, but I thought they would look at the structure of the formatting string and say, you know what, we can drop out 90% of this, but obviously not. Anyway, it's working. Yep, nice and speedy. I will plug something else in, shall I? What's the time? 11:38. Someone just messaged me that I'm not expecting. Some Prince of Nigeria. Well, I'm just going to reply back. They want me to send some money, but I said, you've got to send me some money so that I can send you some money. I was expecting the Spanish Inquisition, so that doesn't count. Now, I actually will end up using these two devices because one of them, like this one here, I'll probably use for... So this is my iPhone cable, my lightning port. So I want one for the lightning port and I want one for the USB-C port. I might have a third one too because I want one for the MagSafe port. Because of MagSafe 3, that plugs into USB-C. Let's see, let's plug it in. Yes. Why did you just die? Oh, dodgy port. Dodgy port. Nice. No, yeah. Dodgy port from the Dodgy Brothers. Yeah, it did die it out again. It's the ports on the laptop, not that. Wow, that really is shonky. Was that always my problem? Yeah, we're going to use... with these cables, they do get junked up every now and then, so this is one of the times where I do use the spray. Oh, that was freaking useless. The graph is fairly accurate. Wow, this... And it is self-scaling. Hey Harold. Yeah, that's really shonked up. Let's see if I can find something else. Yeah, I don't believe I have anything else. Alright. It's fine, let's get a full overhead. And we can zoom out now. Alright, well I'm happy that works. I'll have to push that firmware up to my Git server afterwards. Make sure it's all preserved. I'll switch back to this one now. Aha. Yeah. Wait. Which way is up? Funnily enough, it looks like this USB port is a little bit iffy. The mini port. Yeah, what to do with this one? Anyway, so yeah, I could probably hand out a couple of these ones. Sure, some people find use for them. And like I said, you sort of couple them with, if you've already got one of these. So you use one of these on the machine and you use that other unit as the data link to the PC. Let's go have a look at a MacBook. I think we need to do that just to make ourselves feel like we're accomplishing something. What do we got here? Come on. Beep. Thank you. I don't know if that actually worked or not. No. For some reason I can't see my job data. Vladimir, I believe it is, yeah. Let's see, what have we got? Except the damn thing is in inches, but yeah. What? That's not right. That's 6 inches. Oh, right, 9 inches, right. There we go. No, Paul's been running around all day today. I haven't even had a chance to watch any movies today. Not even his own. This is why people get frustrated with people like Lewis Rossman. The smell of metho, which is basically just ethanol. Ethanol with a bittering agent. They don't denature it here anymore with methanol. They just have ethanol and a bittering agent. So we've got an M1 board and it looks complete shite. Oh god, yeah. Yeah, this one's been in the swamp and then someone's been kind enough to actually wash it. Bravo. Oh yeah, that's like a full... Both of those 17s are going to probably have to be replaced. Yeah, how far did this go? Didn't get to the backlight, didn't get to the ISL. Okay, might be able to recover this. Kind of looks like it got in amongst the Thunderbolt section, so that's a bit of a problem. Did get up here a bit. It's also a bit of a problem. The first thing we're going to have to do is replace that connector. Ah. Thanks. Yeah, so I'm going to have to replace that connector, and like I said, someone's washed away the corrosion that was here. They probably were thinking, hey, if I scrub it away, it'll fix it magically. But the 17s have been badly damaged, so they're probably both going to have to be changed. Yeah, it's definitely a data recovery job only. I'm not going to take the risk of it coming back at me. Hey Paul, how? Yeah, I've already got the schematics and the board views for these boards. This is the 2016, I'm pretty sure. I've also got the 2020, and we've got the newer ones too. I was lucky enough that managed to secure them. The trouble is, no one's actually willingly releasing them. I have to actually go out and chase them down and coerce people to let them out. Yeah, there we go, 2016. And that's exceptionally frustrating. It's like, what we've really got going on at the moment is we've got an east versus west sort of firewalling happening, whereby the east is not releasing this stuff to the west anymore. Or yeah, they lock it up in their own software, but they don't actually share it out anymore. Which is unfortunate. It's the way it goes, because basically there's money in being able to control this sort of stuff now, even though it is technically the black market. Yeah, so this is the board here. So we've got a whole bunch of damage over here, and we need to change that connector. Okay, so yeah, the first thing we're going to do is get that off, because without a working connector, well, we can't be guaranteed our results no matter what. Thank you, Andrew. So what I'm kind of hoping for is that the open board data initiative sort of forces the hand of a lot of places. So I figure if we've got open board data, it kind of takes away some of the advantages that other software packages have. I mean, I won't deny it's also, it's a strategic move by me. I'm using the open data, open source banner to make the data open so that then I can take advantage of it in my own software commercially. So I'm not hiding that fact. Fortunately, at least it looks like those pins are all good. Come on, heat up. Harold, I need to make an order with you to get a couple of those USB-C chipmunks from you. Can I just order them direct from your site? I imagine I can. I'll just do that. Okay, there's a bit of water damage over here. I'm going to clean that up. Yep, we'll do, Harold. We'll do. Thanks for actually putting all the effort into getting those things ready, for the rest of us to use. I mean, the original chipmunks are really good, so I'm sure the USB-C ones are going to be just as useful. Okay, there's a little bit of an imbalance in the solder here, so I'm actually going to do what I very rarely do, and that is use a bit of wick with the soldering iron, just to wipe out. So I'm not a big proponent of using wick directly on the board with a soldering iron. Yeah, clearly I'm not very good at this. Wow, that's really bad. How do people do that for a living? Honestly. Tradie Trev, yes, that is correct. There's always concern that you will just snag a trace, or just something that will go wrong. Because mainly the problem with using wick directly on traces like that is that sometimes a part of the wick can go cold, and then when it goes cold but you're still dragging along, you don't always feel it when you're lifting off a trace. It's kind of like when you're in a supersized dump truck and you start accidentally running over children. So yeah, a bit like that. Okay, that one looks very nice. We'll take this one. Give it plenty of flux. Yeah, I need to get a bit closer to the extractor. So obviously I don't want to melt the connector, so I've just got to be a little bit patient. I mean, I was using 470 when I took the other one off because it was a dead connector and I just wasn't in the mood. By the way, I noticed that there's the P letter up here and IPX down there, so we're going to try and maintain that orientation. So getting connectors off this way, yeah, if you keep the flux there, it shields the plastic from damage for the most part. And it's just a case of being patient enough. If you're in a hurry, this is not the way to take them off. This method does not reward being in a hurry. That was running at 360 with 70% air. And yes, as Harold says, the flux is thermally conductive, so if you keep the flux there, it does help a lot in terms of distributing that heat and making it so that things actually get where you need them to. It is definitely a bit harder to put them on. I won't deny that. It's not impossible, just again, it just requires a bit of patience and hope. At least when you're putting it back down, you're dealing with the leaded solder, so yeah, it doesn't require quite as much patience. But you do need to give it a bit of time. Oh, there you go, one side jump. Because you need to get those inner legs also liquid. And probably doesn't hurt to give it a little bit of a tap. Well, not so much a tap, just a nudge to try and get things to, yeah, like that. Okay, that's a little out. I think I'm going to have to tell myself to stop and go with that. Now, as soon as it's cooled down enough, you do need to scrub that flux off because it is slightly charred. So you don't want it to become like encrusted amber. You heard me. There will be some that you just can't seem to get off that connector. Not much you can do about it. Mostly you just don't want it on the contacts. Hey Patrick. Yeah, there's a bit of encrusting of the flux. Like I said, fortunately it's not on the contacts really, so we're good. Just going to use whatever you want to call them, Q-tip, earbud, whatever. Let's see if I can't give it a little bit more oomph. Because my OCD is getting me. Yeah, ultrasonic will get it, but I want it now. Maybe I'll get the angle grinder out. Or some 80 grit or something like that. Okay. Alright, leave it alone, Paul. Okay, now the downside is that with all that wishy-washying around the place, we've kind of taken away a bit of our watermarks off the back here. But that's okay. We know basically it's a complete and utter disaster, so we need to take that off, that off, that off, and then work from that. May as well take this off. It's not doing any favors to us. Dremel with a wire brush. Sounds good, yes. Crikey, Harold, that's some seriously cold weather you were dealing with there. I'm kind of curious to see what the USB-C input is actually giving at this point. Ah, crud. I just realised it's past midnight. I'm in trouble now. Hey, Godfrey. So we've got 5 volts, 200, 20. Oh wow, shit, it's actually getting 20 volts. Alright. In view of the fact that it's getting 20 volts and the fact that this is going to be a data recovery job, I may be better not doing anything further. Interesting, the second port is not getting 20 volts. That is something I've found with the 2017s, is they will give you 20 volts on one port, but not the other. So this top one here, we're going to replace that. Although then again, I may just simply say to the customer, bottom port only, get your data off, walk away, consider yourself happy. I'm just going to plug it in the machine and see if it actually boots. like I said, for data recovery situations, if you have a point where you are able to boot the machine and you feel like it's stable enough, then you really just need to stop right there. I've replaced that connector too. One of the big pains with a lot of these newer machines, oh yeah, I mean, those connectors are an absolute train wreck. One of the big pains is, I can't remember what I was talking about. Damn it, I hate it when I forget my train of thought. Ugh, there was probably some poignant statement I was going to make that would have changed the world, and well, now we're just going to be stuck with what we got. I'll try to find a way to blame Caradog for that. Mostly because he's not here. Yes, if people did proper backups, I wouldn't really have much of a job. So for that reason, I continue to suggest people don't back up. Realistically, I think Apple could probably sort it out very quickly if they just simply, as a policy, when you bought a machine, you had an iCloud account for the warranty of the machine that had enough capacity to hold all the data that machine. Like if you got say a 2 terabyte machine, you get 2 terabytes of iCloud for the warranty period. And if you want to carry on after that, that's great, good for you. If you don't, good for you. Yeah. And if they did that, of course, people are going to cry blue murder because of the fact that you're just going to steal our data. And maybe there's some truth in it. I don't know. Although from what I've seen with the way Apple encrypts things, they are actually going out of their way to make it that even if they wanted to, they cannot decrypt your data. They're basically saying, we don't want anything to do with it. We'll charge you $1 for the devices and the hosting and all that, but we actually don't want, we want to be able to say, when the government comes along, the FBI or whatever, we want to be able to say, we cannot extract that data because we do not have the key. The encryption is set in such a way that we can't do that. Encrypt with ROT13. You can only encrypt with ROT13 if you do it twice. If you do it once, you're just an amateur. ROT13 is a double encryption standard that you must adhere to. Yeah, I can't remember which port it was that was working versus the other. Yeah, that's the 20 volt one. With charging, then we just dropped down to 20. That could have been just the reboot. Yeah, we're booting. I've got a progress bar coming up. Yep. You can see the person's thing there. Okay, we're gonna leave that one there as is. We're not screwing with this. I'm just data recovery only. Job done. Okay. I'll just write that one up. Advise the person they can only use that one port. I'll put in another one of these connectors. Just advise them that port only. Be happy, you get your data, walk away from it. Because realistically, with the sort of liquid damage that we're looking at here, there's probably going to be damage in the screen, there's probably going to be damage in the keyboard, there's probably going to be damage in the trackpad. Yeah, it's maybe not everything, but chances are it's going to have wicked somewhere and might not be playing up now, but it probably will play up later. So yeah, that's how we're going to do that. I'll just have to get another one of these offset angle connectors like this one, because they actually fried that pretty good. Have a look at that under the microscope. Yes, I need my beauty sleep. I also need to play some zombies with Elita. Yeah, look at that. That's some... It actually delaminated from the heat. That one basically survived, but yeah, this one... And it looks like whatever they were using as a charge cable was starting to chew in on their cables anyway. Yeah, anyway, all good. We're out of here. So, thanks for watching. See you next time, and yeah, I'll see what we can do about offering these up for people. If people are interested in the non-display version of this USB-C meter, and as you can modify the firmware or whatever. I haven't actually done a Windows version of the software yet, but it probably is about time I did. But for now, it's all Linux. But it's the protocol's easy to understand. It's just 9600 bits per second on a COM port, and you already saw what I'm doing. I'm just pumping the 4 bytes, and from there you work out the rest. So, all right, I'm out of here. Take care of yourselves. I'll see you next time.